Hey everyone, Pete here. Welcome back to another video. In this episode we'll be going through the build of the Route 3 Lite CNC machine in real time so you can see how I assembled it. Let's build a Route 3 Lite CNC machine. First things first, let's go and get some parts. Steel box section. Only got steel because it was the only thing they had in the store. I would have gone for aluminium, but this will be fine. One baseboard. Then we're going to build on 8mm smooth threaded rod. 4 core. What is this? 4 core 26 AWG cable. I'm going to use that for the motors and end stop switches. Get rid of that. Spray paint, a bit of an optional extra, but I'm going to spray paint these wooden boards. And some side panels. As well as that, we're going to need a selection of M3 screws. This is just my collection, but you don't need all of these. I think I'm going to use a standard set of screws. So we're going to need some M3 penny washers. These are 9mm, 3mm inner diameter, 9mm outer diameter. I've got a selection of Loctite M3 nuts and a selection of standard M3 nuts. I think I'm only going to be using this selection of M3 screws, but with most things you see how you go really, but I'll try not to touch any of this and keep it standard to these bags so it's easy for someone getting into it. M5 threaded rods, bolts even. Now these are just M5 by 600mm long. They'll be used for the carriages. And to go with that, we're going to need a selection of nuts, washers, and then some other nuts as well, used for hold bearings on the carriages. Now some plastic parts and some other electronics. Oh, and a little helper maybe. You're going to give me a hand, are you? Yeah? Here's one of our little 2 helpers. And you're going to stay there, are you? Printed parts. Alright. So for this build we're going to need 4 NEMA 17 motors. The higher the torque the better. I'm going to be using for this build a 400 watt quiet cut spindle. I think it's the same ones they use on the Shepukus, I think. But we'll be using one of them. This motor was originally used on the original Route 2 CNC, and that I used quite a lot of, so I know it works quite well. We're going to need a closed loop belt for the Z axis. Little LED lights. I'm going to put some lights on the underneath so it should illuminate what you're working on. Leave that there for the moment. For this, going to be using a ramps board with the DRV 8825 stepper motor drivers. Used this a lot, got quite good success with it, so I'm quite happy to use that again. I even use it on this large CNC using NEMA 23 stepper motors. So large NEMA 23s running off exactly the same board. You might be able to see it just hanging on the wall right there. These are drag chain cable mounts. We use this to do our cable management towards the end of the build. I find it's easier to buy this stuff rather than printing it. It's cheap enough as it is. So 2 of them. You probably could get away with 1 length, but the trouble is you need the end mounts. So I've not bothered designing it. I've got loads of this stuff, but I prefer just to use the end mounts that come with them. We've got them. Right, for this build we're going to be using a selection of 5mm bore 16 teeth GT2 pulleys. This is just my selection of bits, so we're going to need 2 for the Y axis, 1 for the Z axis, and 1 for the X axis as well. As well as that, we're going to need some 8mm bore pulleys. These don't have to be the same, but as long as they're used on the same side, the same number of teeth on both sides of the machine, should be fine. So I've got some 8mm bore GT2 pulleys. These are 20 or 22 teeth, and will also be used for the Z-axis lead screw. I've got a selection of spare bearings. I don't think I'm using them bearings. They're just what's in my kit. So we're going to need them. With the pulleys, you're going to need some belt to drive it. So that's just some 6mm wide GT2 belt. It's just fairly standard stuff. Now for bearings. I don't know off the top of my head what they are. Hopefully it will say. These are the 625 RS bearings. Check the bottom to how many you need, but these are all the ones I've got in stock to try this out. Them. And we're also going to need some 608 ball bearings as well, the roller skate ones. So these are the standard ones for Route 2 and Route 3, but for the Route 3 Lite we'll be using the slightly smaller ones. As well, but I haven't opened it, we're going to need a selection of 4 LM8 UU bearings. I've just got a pack of 10 or whatever they are, 12 pieces I'm going to be using. They're new, these are slightly used, so I'm going to use the new ones. Pack of them. We're going to need a 8mm lead screw. This will be used for our Z axis. Now, the machine can be driven with lead screws all round, but I've just not designed them parts. But by building this machine, it's easily upgraded in the future to use lead screws on all axis. But I'm going to cut this down to length, but this is just a 8mm trapezoid lead screw. I think it's a 2mm pitch. You can go higher. I've got a 4mm pitch lead screw on my Route 3 big machine, the one you can see here. That works fine. I've not noticed any problems. I was concerned about the pitch, but nah, perfect. Right. Some end stops. You're going to need 2 per axis for Minimax. So these are, check the bottom, so I don't think they're the same code that's on them. For them, get a selection of them. What else? I'm no doubt going to forget stuff, but I'll try and keep tabs on it as I go. Now for the printed parts. Okay. Let's get these lined out. I think you could get away with a 1 kilogram reel to print all of these, but with my printer playing up and having some failed prints quite late on, I've had to use a 1.5 reels worth of filament. But if you've got a reliable machine and you can print it all in, print with no issues, then yeah, you can get away with just printing it with a kilo, I would imagine. This should be all the printed parts. We'll find out when we come to assemble it if I was right or wrong. So yeah, I'm just trying to think if I've forgotten anything. Right, I think first things first. Let's get these baseboards painted and let them dry whilst we start assembling the rest of the bits. I would like to add these parts. I've printed this in ABS, but as most of the parts hold the machine together, it is recommended that you do pick a quite high infill density. These parts are printed with 3 perimeters and 50% infill. They're rock hard. There's no real bend or play in them. But the higher infill and the stronger parts you can get, the overall better machine you should get. So around 50% infill is probably quite good. Oh, these motors have already got the 16 teeth pulleys installed, so I probably won't need them. Nevertheless, we've got them if we need them. What I might also do as well is add some clear lacquer on these parts, just to give the paint a bit of a strong coat. We're going to be using it. You can see this is just normal wood paint that I've used on this one. You can see it's taking a bit of scratching. But I might put some clear coat on just to see how it seals it, because after all it's just spray paint. Before we go outside and get that painted, I want to drill these holes out so I can put the same M6 threaded inserts into the baseboard. I can show you them. As you can probably tell, I've not planned this, I'm just winging it and seeing how we go, but my plan is to stick a load of these in there, so I need to measure and drill these extra grids ones out. Eight mil drill bit, I'm going to get drill. Alright, get that brushed off, cleaned up and spray painted. Right, whilst that's drying outside until we do the next coat, we'll prep the printed parts and get them ready for assembly. Right, each carriage has a M5 bolt. What length is it? 20mm length bolt. It will have 8 washes in total per carriage, before and after bearings, and then 4 bearings. You can use Loctite nuts on this, or lock nuts on this. Probably recommended, but not got them, so regular nuts should do fine. If I can get it on the thread. And then just tighten them down. Make sure they're tight enough so it's not going to vibrate its way loose. And there you have it, your first carriage done. With these carriages, exactly the same thing, but what I like to do is get the bearing pressed in first. Now I've got no fancy way of doing this other than just put it on a table and push down, making sure it's perpendicular. And there you have it. One bearing pressed in. Whilst I'm now do the other one. Make sure it's fully pressed in. It should be nice and flush with the plastic. Now for the Y-axis or X gantry bearing link arm. Definitely needed if you build in any of the root free or root free Lite machines, as this link will make sure that both sides of the machine stay relative to one another and they don't slop around. Now with these lead screws, I bought a pack of 3 of these from China, and I've already used a couple of them, and this is the last one. but some of them don't rotate as freely as you would hope. So I put it in the drill and just run it up and down just to hopefully take some of the edge off it and let it wear itself in a little bit. So that's fine. We'll use this one. It's running a lot better than it was when we first got it out. Next, we'll take our lead screw nut and insert into the carriage. Now, your mileage may vary, but these holes are done so you can pretty much screw an M3 screw straight into it. So that's what we're going to do. So, unfortunately, my phone decided to cancel the camera or it decided to do its own thing. So, you might have missed me putting in the 8mm linear bearings. They just popped straight into the carriage, quite easily done. And also inserting the lead screw nut into the block. I didn't tackle any of these, I just screwed it straight into the plastic. No issues here, just to make sure you tighten it up, make sure it's flat, and you're not tightening it on an angle like you would do tightening a car tyre. Do opposites and diagonals. So that's that done. I did both of them, so they're now ready to go. And then I started talking about the Y-axis belt idler. Now this is the same as what was done on Route 3, it's just a small, scaled down version. And instead of using the 608 bearings, this uses the 608 bearings. This uses the 625 bearings with a 5mm rod rather than an 8mm rod. Oh, one of the rubber seals has come off. I won't use that one. So what we need to do is, with a file and saw that I got off camera, is get two pieces of rod, 30mm long, that will fit in here, and we can insert the bearings into it. So just so you can see. I'm going to use that in the vise with the hacksaw, and to keep the outside of the rod smooth, I'm going to use just a bit of blue rag to hold it in the vise. Right, that's one done. Now for another one. So this is just standard 5mm smooth rod that I bent for a candy cane during Christmas last year, but I'll still take the straight bits off the other end. As long as it's straight over the small length, it'll be fine. Right. Now from hacksawing it, it does leave an edge on there, so what I'm going to do is put it back in the vise and just quickly file off the sharp edges. So that's my two little Y-axis, X-axis idlers, and then they will go into this block here. So what you need to do is get 3 rotary bearings and just slide it onto the rod, like so. Same again on the other side. Right. Now get your printed part, and it should slide in. It doesn't go down vertical, it goes down at an angle, like so, and that's it, clipped into place. Very nice. Same again on the other side, just down and in, like so. That's done. So you can see from there. Whilst I've still got the hacksaw and file out, I'm going to do the 8mm rods as well whilst I'm here, so I can put the tools away. Now, I'm doing a fairly conservative size, and I'm only going to be using having a even XY axis of 350mm of box section. Now you can make it bigger, and then that would make your connecting rod bigger. But for this I'm just going to use the standard size I've gone for. As well as the connecting rod, there is also the Z axis. Now, as this is the Lite version, it's using the linear bearings rather than the linear guides that are better but do cost more. But for this application, what this mill's designed, well, I've got planned for this mill, will be more than suitable for the job. So, if I do the Z-axis rods first, I need to do 160mm, and I need to get 2 of them, and that will sit in. That'll be the smooth rods for this. Now, it might have been missed on the camera, but I'll repeat it anyway. These rods, you can buy them, or if you've got an old photocopier or a scanner lying around and it's probably going to go in the tip or get thrown away, you can salvage these parts out of them, and they're normally quite high quality and very good. So that's where I got these from, just scavenged them out of an old scanner, print scanner, so it was good. Right, same again, measure this one out, and 2 160mm rods. Same again, just going to run the file over just to take the edge off them. And I think I know this is probably just the wrong length. Yeah. 5mm longer than the bill of materials, so I'll probably leave that. I'll come back to that if I need to. Right. Moving on to the steel rods. The finish on these steel rods aren't great because they, I don't know what they put on them, but they stop them from rusting. Now, these are steel rods that I've taken the coating off to get a really smooth finish, and this is out here in the garage and it hasn't rusted. So I'm going to do the same with these ones. I would ideally like to get aluminium ones, but these are handy. I can pick them up from Wicks and get them the same day. So what I'm going to do is cut this down to 4 350mm lengths, and then I'm going to wet and dry these down for our axis. Right, let's crack on. Same again, I'm going to do this in the vise using the little bit of cloth. That's just normal tap water, nothing special. Get them out of the way. Choose the lowest grade I've got. Right, so you can kind of see how good the steel turns out. It's lovely and smooth. I'm going to do all of that for all of them. I'll definitely be fast forwarding this bit. So if all goes well, you should have a nice, shiny, smooth steel set box section to be used. Now you're taking this coat off, it will rust, potentially rust. I haven't had it on this, but there is a likelihood of it is. But if you do it indoors, you'll probably be alright. But just a bit more wet and dry and a bit of oil. I don't know what that was, but the camera decided to stop. So that's one done. I'll crack on and get the rest done. Alright, now we have our nice and smooth box section. Now doing this will make your machine a lot quieter as well as run a lot smoother. So I do recommend doing it. But obviously if you buy aluminium straight up, the surface finish should be good enough to not worry about it. Get one of the old bits for comparison, so you can kind of see. Let's find the weld. Where's the weld? Oh, there you go. So that's the two sides as it was before. Yeah, so you can use steel on this machine, and it works fine. You can see here that there's a bit of extra rubbish there. Not too worried about that because these will sit in the plastic blocks. So as long as the bit where the carriages run is nice and smooth, that's all we need. Right, now to fit these into the blocks. Now, in previous versions, it was these blocks had to be in the right place. On Route 2, there was an idler and a mirrored idler and a motored side, but with Route 3 Lite, both of the blocks are the same, so you can have your end stop either side. It means you only have to print 4 of one rather than 1 of 4, if that makes sense, of individual parts. These are just all the same parts, so you can use it either or. Now, there's some forward planning needs to go on here because I'm going to be mounting end stops on effectively this rail. I want my cable to run through the tube just to make my build look a little bit nicer. So what I'm going to do, I'm going to leave it on the reel for now. Take one of the blocks and you can feed the cable through the block into the middle. Now it does take a little bit of encouragement. There you go. But it can just push through. Pull a length through. It might be a bit too much that. And then get one of your box sections and run it down the middle. So I'm going to use this cable that I'm running down here as the home stop, the minimum travel end stop, and also I'm going to do what I've done on this mill and put a probe. I can connect a probe up to it as well. So when I come to use a probe, very good if you're using it for PCB milling, that you can attach a probe quickly and easily with just a few banana plugs. So that's what I'm going to do, exactly the same setup, end stop here and then a probe to touch off. Now to get this in the hole, just push it down until you get to the bottom. Job done. And then same again, pop the cable back through, this time going from the other side. And then getting that into the hole. I'm just going to tap it for encouragement. Most of the time these go in fine, but I just want to make sure it's in. There is one of your axes ready to go. So I don't want this bit of cable staying on here for a while, so I'm just going to give myself a sensible amount and chop it off. Alright. Then you can pull it through so you can get a nice length. That should be more than enough for later on. There you have it. Repeat that for the other side. And we're getting there. Now for this one, as I'm only going to be using one end stop, two end stops per axis, the other side isn't going to need any, so the box section can go straight in. Double check the same length, and we are golden. So, as you can kind of see. Now for the x-axis. Now as you can push these right through, you're going to make sure that you just go flush with the back of these. It's not a problem if you do push it too far, you can pull them out. Now I found if you do both of them at the same time, it makes it a little bit harder getting into the other block. So leaving one side a little bit shallower than the other side will just make it easier to get the other side on. And before I do that, make sure they're the right way around so they can go on. Right. You can see here there's an option for a 608 ball bearing here. Again, this is a future provision for lead screws on the x-axis. I'm not going to put a bearing in here because I'm yet to do it. I'm going to be driving this with belts, so that's fine. Now, oops, I'm just going to make sure I've just pushed one a little bit too far forward with the mallet. Right, now to mount the carriages on your axis. Look how diddy it is. Right, so we're going to have a top, a bottom, and then two intermediary ones. Right. Bolt these down. One other thing is, this is an optional part. It's not necessary, but what I'm going to use this part for is to put an LED strip light in. So this will be mounted on the bottom side at the bottom, so we can affix some lights to it to illuminate your work. So what I'm doing now is putting the bolts down from the top and fixing the bolts to them. Now I prefer to put bolts on the inside as well, so it ensures that you're not the part is at equal distance no matter what type of load's underneath it. Now if you just had the nut on the outside, it will just, you can forever tighten it, and if it twists it can I just think it's better basically. So I do recommend. It's a bit more fiddly, but I do think it's worth it. Like so. I'll tighten these up before moving on. As you can see, just 4 bolts. Now I'm not going to do the same on this part. I'm going to do it the same on this part, so all the bolts face down. Putting this video together has made it longer than I thought it could be, so I'm going to split this up into multiple episodes, so please like, comment and subscribe, and stay tuned for the next one. See you soon. Thanks. Bye.